So I have a cup of coffee whose temperature, which apparently we're calling H for some bizarre reason, right, is a function of time, and it's given by 70 plus 120 times 1/4 raised to the t power. So, question, where is this going to end up in the long run? If you put a really big number in for t, what are you going to get out of this thing?
Cold coffee.
Yeah, you should get cold coffee, right? Duh. That's awesome. So let's check and see if this model gives us cold coffee. So if I plug a big number in here for t, what's 1/4 raised to a really big number? A really small number. What's 120 times a really small number? Basically 0, right? What's 70 plus basically 0?
70.
Basically 70. 70-degree coffee makes sense?
Pretty chill.
Sure. But sitting out in a 70-degree room, right? That's what this number is. That's the room temperature, right? So they're asking me, what's the temperature initially, right? So I just calculated what kind of like the limit t tending to infinity of h of t is, right? I just calculated that to be 70. Like what happens in the long run? You get cold coffee. So they're asking, what's h at 0? So when you plug 0 in, what do you get? 70 plus 120 times 1. So you get 190.
It's pretty hot coffee.
So that's fairly freaking hot coffee. You're a barista, right? What's coffee come out of the, when you pull a shot, what's the coffee come out of?
It's like 180 something.
Yeah.
Brewed
That's
coffee
legit.
is like 210. It's pretty hot.
Yeah, this goes back to a thing. Do you guys all remember this like extremely frivolous lawsuit that this woman brought against McDonald's for?
Yeah, because they
Have you
didn't
seen
have
the documentary
content
Hot Coffee?
hot. Yeah.
Yeah, the funny thing is she had like 3rd-degree burn.
Yeah, I was going to say it's not frivolous.
No, it was not frivolous at all. It was very well deserved. They served her coffee that was literally boiling.
Well, didn't they give her like a cup that like wasn't? Like,
Yeah,
you
they also
could
gave her a
anything
cup
on
that
it?
wasn't designed for it, so as soon as she touched it, it just went.
Yeah.
Okay, anyway. 190-degree coffee will probably burn the shit out of you. Okay. After an hour, after 2 hours? So after an hour, how do I figure out after an hour?
Plug one.
Plug one in. So I get 70 plus
A quarter of 120.
a quarter of 120, so I get 100.
Yeah.
And h of 2,
The
77.5.
you're going to get a 16th of 120, which is not very much. So like 77, you're telling me 77 and a bit. Okay, that seems legit, right? Okay, so every hour, what's it doing?
it's getting colder.
Yeah, every hour it's getting colder, and it's getting colder by,
A lot.
A little over a quarter.
it's getting colder by a quarter of how much hotter than the room it is. You guys see that? That kind of makes sense? That's actually Newton's law of cooling there. That's saying the rate at which an object loses temperature into a room is proportional to the difference between its temperature and the room's temperature.
So a quarter of that difference.
Yeah, so this is cooling at a quarter of the difference every hour, basically.
Well, that's when the
Yeah.
temperature stays of the room stays consistent.
Yeah, that's when the room stays consistent. Newton's law of cooling does not apply. So Newton's law of cooling does apply if you have a hot cup of coffee in a big room, right? It does not apply if you bring in like a 55-gallon drum of molten salt into a room like this. Why?
Because that will be very hot now.
Yeah, because that'll raise the temperature of the room.
Quite a bit.
You guys see that? Like it only works when the room can basically absorb all the energy without changing temperature. If the room can change temperature too, then you have to do more complicated things.
Limitations.
Okay, let's see. What else were we supposed to do? How long does it take the coffee to cool down to 90?
Let's just plug in 90 for T and then, I mean for H and then.
Yeah, so if you want to do the other ones, right, you plug 90 in for over here. What's your procedure for solving? I'm not going to actually do this, but what would you do?
Subtract 70 or something.
Yeah.
Subtract 70,
Divide by 120.
divide by 120,
Take the log of both sides.
log both sides.
And then divide by log of 1/4.
Yeah, do some stuff with log rules. So log rule and then divide. You guys got that, or should I do this?
And if you want to do it, I wouldn't mind.
Okay, so let's do one. So I got 20 is 120 times 1/4 raised to the t, right? And then I'm going to divide by 120, so I'm going to get
6.
1 over 6 is 1 over 4 to the t. Okay, then log both sides, so you get log of a 6 is t times log of 1/4. I cheated. I used a log and a log rule at the same
You
time.
pulled the exponent to the coefficient.
Right, I dropped the exponent. Yeah. You guys all with that? Okay. So then what?
Just,
Divide. Divide by the natural log of 1/4. Get natural log of a 6 divided by natural log of 1/4 is
Natural log of 1
is what was this supposed to be?
1.292.
There's no other log with that, right?
No, what was the other side of the equation?
Oh,
T.
T.
T. Okay, and then you guys figured out that T is like give or take 1.2. So if I go over here and check, like, to get to 90 degrees, I'm going to have to get to 100 degrees first, and then go a little past that, right? So I'm going to be a little past an hour. Am I closer to an hour or 2 hours?
An hour.
Should be closer to an hour, right? Okay, so that seems like, yeah, this is closer to an hour than 2 hours. So if I was to write this like a human being, as I encourage you to do with word problems, you would write,
This coffee would be cold.
ooh, yeah, careful with that. Hours aren't made of 100 minutes, right? So 0.2 hours is not 20 minutes.
That's 65.
So 0.2 hours is 12 minutes. So it takes 1 hour, 12 minutes to get to, what was the temperature I set this
75
equal?
degrees.
90.
Was it 90?
Yeah.
It was 90.
And then to get to 75 degrees, we do a similar thing. What would I ballpark 75 degrees as?
A little over 2 hours.
A little over.
Yeah, like 2 hours and a couple of minutes.
2 hours and 2.3.
Sure. Cool. Questions, things? Kind of make sense? Yes.